Assalamu alaikum, students. Now I have another question which is related to stationary points, but you can see it's the application of product rule. Your values of x are from minus pi by 2 to pi by 2. He says that you need to solve this question for stationary points. Yani I need to put dy by dx equal to 0 to get the value of x. Okay, so what we need to know first, we copy the question, and it is clearly seen there are two functions multiplying with each other. To get the stationary points, I need to get the dy by dx, and when the two functions are multiplying, we need to apply the product rule. For the product rule, first function we will keep it as it is. Now we need to do the differentiation of tan square. Guys, tan square of x, how do we do the differentiation? First, we hit at the power, apply the power rule, power goes back, keep the function as it is, argument as it is, and from the power you subtracted 1. So this is the power rule you applied. Then next job is take the derivative of tan. The tan derivative is secant square and keep the argument as it is. Next further derivative is x. So x derivative is 1. So in general, I'm going to get 2 tan of x secant square of x. This would be the derivative of tan square of x. That's why I have selected this question, so that the students can see the differentiation in depth, where I kept on applying the chain rule. So the tan square x, I'm going to write 2 tan of x, then the further derivative of tan is secant square of x, and the further derivative of x is 1. That's done. And then I leave tan square of x, take the derivative of e raised to minus 5x. I will keep e raised to minus 5x. Further derivative of minus 5x is minus y. Now the time has come for simplification. Yeah. So I will write 2e minus 5x tan of x secant square of x minus 5 e raised to minus 5x and tan square of x. You can see I kept e raised to minus 5x as it is, so I have shaded it as green, and then tan square of x in the second term, it is shaded as blue. After writing this expression, I know he's asking stationary point, I need to put it equal to 0, the derivative equals to 0. But before that, is there anything common? The answer is yes. E raised to minus 5x, and one of the tan is also common. I can take it out. So e raised to minus 5x and tan of x will be taken out. So you get 2 secant square of x minus 5 tan square of x. It is equals to 0. Imagine in my last video and in my explanations, exponential function can never be 0. So ignore it. Now tan of x, it is equal to 0 where? Yes, where? Maybe 0, maybe pi, maybe 2 pi. Did he include them? No. His range is from minus pi by 2 till pi by 2. So the 0 is included inside it. So it means I have to take just 0, not pi and not 2 pi. So first answer, I got it. That is x is equals to 0. Now the third factor, we put it equals to 0. 2 secant square of x minus 5 tan square of x is equal to 0. Why do you remember the Pythagorean identities which I have taught you? One was sine square x plus cosine square of x is equal to 1. 1 plus tan square of x is equal to secant square of x. And 1 plus cot square of x is equal to cosecant square of x. Will you allow me to use this Pythagorean identity? So in the place of secant square, I'm going to write 1 plus tan square of x minus 5 tan square of x is equal to 0. Okay, so this is very important for you. The identities. Open the brackets. So 2 plus 2 tan squared of x minus 5 tan squared of x is equal to 0. So minus 3 tan squared of x plus 2 is equal to 0. 2 is equals to 3 tan squared of x. 2 over 3 tan squared of x, and then put the square root. So plus minus 2 over 3 is equals to tan of x. I'm going to write here tan of x is equal to square root of 2 over 3, and tan of x is equal to minus square root of 2 over 3, since I need to cover the first and the fourth quadrant. So let me draw the quadrant diagrams here. Okay, so since the tan is positive here, so I'm expecting my answer in the first quadrant and the third quadrant, but since the given range is not covering the third and the second quadrant, so I will stay here, and I'm going to write here shift tan of square root of 2 over 3. And in the second equation, the tan is negative. Tan negative is in the second quadrant and the fourth quadrant. So I'm using this one because it comes within the range. What is the basic angle? The basic angle is still the same, shift tan of square root of 2 over 3, but I need to drag this answer in the fourth quadrant. So I'm going to write here pi, 2 pi minus, because the given range is given in radians. So don't write 360 minus. So we need to write it as 2 pi minus shift tan of square root of 2 over 3. So use your calculator, and your calculator has to be in a radian mod. Yes, now it is converted. I'm going to write shift tan square root bracket open 2 over 3 bracket close 0 0.685 0.685, and here I'm going to write 2 pi minus 0.685. So that gives you 5.60. 5.60. So these are the two answers. I got it. Uh, since the ranges are pretty simple with us, and I don't think so we need to add and subtract 360. Find the x coordinates of the stationary points. Now he didn't say point, just points. So I found the x coordinates. So x can be 0. How many decimal places? I didn't check that. Three decimal places. So 0.685, and the second one was 5.598. 5.598. So these are the two possible x coordinates. Thank you, boys.